In this video, we will explain the test we use to measure and establish the operating current of our connectors. This test is governed by IEC Standard 60512 Part 5-2, which states that the maximum current carrying capacity of a connector is determined by the current that causes the hottest spot within a connector body to rise 30 degrees Celsius above the final ambient temperature. Here we have a standard test setup for a connector current test that will document the IEC requirements. The basic components are a DC power supply, an electronic load, 2 thermocouples, a shorted mating connector, a holding fixture, a vented test chamber built to IEC specifications, and a PC with software for data acquisition. Let's discuss a simplified description for conducting the test. One thermocouple is soldered to the center conductor of the test connector for measuring temperature rise. The other thermocouple is mounted in a holding fixture to measure the ambient temperature of the testing chamber. The connector under test is mated with the shorted connector, and then terminated to the power supply and electronic load. The data acquisition software for temperature monitoring is started. The DC power supply and electronic load are activated. The electronic load current is slowly increased until a 30-degree temperature rise is stabilized. Before the temperature can be considered stable, the connector must stay within 2 degrees Celsius for 3 consecutive 5-minute intervals. The graph contains the results of the test data. There are 2 curves plotted within this graph. One is the maximum operating current based on the 30 degrees Celsius temperature rise data, and the other is that same data derated by 20%, which is then recorded as the operating current of the connector. Derating accounts for external factors, manufacturing variations, and errors in temperature measurement. If you have a unique current requirement, our engineers can help design a cable that will meet your needs, so give us a call.